So welcome back to topic 5 on deep reinforcement learning. So in this topic we'll be talking about reinforcement learning and how specifically we want to train the reinforcement learning model. And in the next step we will talk about the applications. So in training we are trying to determine what's basically the policy to use to determine the best course of actions or sequence of actions that we should take in order to achieve the goal. That's the overall purpose of training in the terms of the reinforcement learning model. So if you're using deep neural networks for reinforcement learning, the neural network is basically determining what's the policy function to use. What is the mapping between the actions and the current state that the particular environment is in. Right, so a neural net can be used to approximate the value function or the policy functions. That is, the neural net can learn how to map the states into a particular sequence of values or state action pairs to Q values. And rather than using a lookup table to determine all the possible states and values, typically we would actually train the neural network based on the input problem. Okay, we use the problem itself as it will give you an indication of the state. And then that neural network will be trained to recognize what is the corresponding correct action to do in order to achieve the overall goal at the end. This sounds very abstract, but it will become clearer as we move along. So let's say we're trying to use CNN to determine how to play. We're trying to use CNN for reinforcement learning in order to determine how to play a game. Okay, so and this is a simple game, a Mario game, where we're trying to avoid obstacles. So in this particular reinforcement learning game, the convolutional neural network is used to recognize the state. Okay, basically the game screen. Where is Mario in the game screen? What should be Mario doing in order to get a higher score and avoid getting killed, right? So we are going to use CNN the way it has been used so far in the earlier part of the course, where we are using as a classifier. But in this case, instead of determining the label as the output, we are going to determine whether or not the Mario should be moving up, moving down, or what action it should be doing, right? So the convolutional network is the same, but how we actually interpret the output of the convolutional network would be different. So it's not to determine a specific label for the current screen. Okay, we're not trying to recognize anything in the screen, but we are trying to determine what is the correct action for Mario to take given this current screen as the input. So the CNN is actually being used the same way as it's trying to recognize the agent state given the visual input, just as we do in image recognition, just to give you a visual feel of the difference between the two. So the input is the screen, right? So the input image is the entire image. It goes to a convolutional neural network as before. And finally, at the output section, instead of trying to label it as Mario is alive or Mario is dead, we are trying to map it into the possible action. Should Mario continue to run or continue to jump in this present screen, given this current state? So in reinforcement learning, given an image that represents the state, the convolutional network can rank the actions possible to perform in the state. So for example, it might predict right now, running right may return 5 points, jumping 7 points, and running left none. So the best action actually is the one to will achieve the best reward, which is jumping, which gives you 7 points. So the above image illustrates what the policy agent does, right? The policy agent interprets. Policy agent is basically the CNN. In this case, right, the convolutional agent, it does the best mapping of the current image state, what the game screen looks like, to the best possible action. And this is just to compare using CNN with the same example, but instead of determining whether to jump or move left or right, here is just a conventional CNN that we've been talking about earlier. We're just trying to label whether the image that we get on the left is an image of a cat or a dog. This is just normal supervised learning. This is not reinforcement learning. Just to distinguish between when it's used for reinforcement learning and when it is actually used for supervised learning. So the structure is similar, but the way that we use the output is different from the CNN. So we have talked about before, the overall goal in the reinforcement learning is not to just use up all your energy and kill the first boss monster you see, but you want to actually improve your score over time, right? To achieve the overall goal of winning the game rather than just beat one single boss monster. So this is where Q learning comes in. So Q learning is the way of mapping a combination of actions that give you the best overall reward given a particular trajectory or particular sequence of states. We want to maximize the return, the Q functions that gives you the highest return overall, rather than just one single instance of time in the game, right? So having assigned various values to the expected rewards, the Q function simply selects the action pad with the highest so-called Q value at this point in time. At the beginning of the reinforcement learning, the neural network coefficients may be just randomized, so you will keep losing in the game, but as it learns more and more moves, it will basically be able to adjust the policy function or the Q function, right, where to be able to learn what is the right values to use over the long period of time and win the game overall, instead of just winning one single move in the game. Okay. So using the feedback from the environment, the neural net can use the difference between the expected reward and the ground truth, the actual reward that it gets, to adjust the weight so that it will improve its interpretation of the current screen. So that it will keep improving as it learns more about the game. So in fact, this kind of technique has been used to playing game like Breakout by the same team that made AlphaGo. Initially, the agent is not able to understand how to win a breakout game, so it will just randomly move the bat everywhere. But as it learns more from the reward function, then it knows that actually if you hit the ball into the brick at the top, then you will get a point. So you will start knowing that, hey, actually I should move the bat towards the ball when it's moving towards the direction of the bat. And after a long, many iterations of training the neural network to improve the policy, it will ultimately actually be able to beat the programmer who wrote the program at the breakout game. He is able to learn new moves that the original programmer never thought of, actually. So this is actually one of the nice things about reinforcement learning is it will learn from its errors and it will keep improving with time. What is the correct sequence? So here are some further references about Q learning as well as the ebook that you can read. Now, Q learning itself, the theory is quite complicated, but it's actually one of the most fundamental ideas behind reinforcement learning, and that is basically how to adjust the sequence of actions so that you will maximize your reward overall.